This is an introduction to slope-intercept form, also known as function form. It will come in the format of y equals mx plus b, where m is your slope and b is your y-intercept, or where it hits the y-axis. Alright, so we're going to try a couple different lines here. Let's try y equals 3x plus 5. Y equals 3x plus 5. Now remember, this is a two-variable equation. It's going to be a linear equation. One way that we could graph it is we could plug in different inputs, get out different outputs, plug in different domains, get out different ranges, put in different independent variables, get out different dependent variables. Okay, so if I put in 0, 0 times 3, I'm putting in 0 for the x, by the way. 0 times 3 is 0, plus 5 is 5. By the way, when you're at 0 on the x, you're actually hitting the y, so that is going to be our y-intercept. That's a special one. Okay, put in 1. 1 times 3 is 3. 3 plus 5 is 8. When I put in 2, 2 times 3 is 6. 6 plus 5 is 11. And those are 3 points that we could graph. So let me graph with those 3 points. First point is 0 on the x, 5 on the y. Next one is 1 on the x and 8 on the y. Next one is 2 on the x and 11 on the y, which is a little bit off my graph, but approximately right there. Then I would graph that line by drawing a line and putting arrows on both ends because it goes forever in both directions. According to the inputs and outputs, that will determine where we are left and right, and also up and down. And that's how we graph y equals 3x plus 5. If I would have graphed it with my understanding of slope-intercept, I would have simply looked at the back and said, you know what, this is my y-intercept, it hits the y-axis at 5. That is where y is 5. So now, from there, I'm going to use my understanding of slope, remembering that slope is rise over run. In other words, the difference of y over the difference of x, how far it's going up or down, over how far it's going left and right. And so when I look at positive 3 over positive 1, that means from the point that I know, I'd be going up 3, right 1, and putting another point. Going up 3, right 1, putting another point. That would be an understanding of how to use that slope from my y-intercept. And just while we're at it, you could also say that a negative 3 divided by a negative 1 is also positive 3. And so another way I could have gotten there is gone from that point down 3, left 1, which will still be on that line if we continue it. I could go from any of these points, down 3, left 1, down 3, left 1, and we'd still end up on those exact same points. So this time we're going to try y equals negative 3/5 x minus 3. Alright, so this time I'm going to put it into the xy table, or the input-output table, whatever you call it, first. And when I have a slope that has a fraction in it, I tend to choose inputs that are multiples of the denominator. So I'm looking at that denominator of 5, and so I'm going to choose 5. I'll still choose 0, and I'll choose negative 5. So I put in 5. That's going to get me negative 3. Negative 3 minus 3 is negative 6. There's my first point. I'll put in 0. Anything times 0 is 0, so 0 minus 3 is negative 3. I put in negative 5. Negative 5 is going to get me an answer of 3 when I multiply it by negative 3/5. And then 3 minus 3 is 0. So I'm going to plot it with those 3 points. So I have the point 5, negative 6. That's 5 on the x and negative 6 on the y. Then I have the point 0, negative 3. 0, negative 3. I recognize that that is on the y-axis, so that is my y-intercept. My next one is negative 5, 0. Negative 5 on the x, and 0 on the y. That one also has a special name that we haven't talked about yet. That is called the x-intercept, because that's where it's hitting the x-axis. I draw a line through those points, going forever in both directions, and that is the line y equals negative 3/5 x minus 3. I'm also going to show you that with an understanding of slope-intercept. The y-intercept we know is that b, which in this case is -3. So I would plot it. Then I would use my slope, remembering that slope, once again, is rise over run. It's an important understanding. And some people get this reversed because they're used to plotting points. When you plot a points, you're going x, which is left and right, according to whether it's positive or negative, and then you go y, which is, of course, up or down, according to whether it's positive or negative. If you look at slope, however, it's telling you from a point you already know the directions to the next point. So I think about these points as being like an address. If you live at 315 West Wisconsin Street, then you go to that specific place. Then the slope is a little bit different. The slope isn't a direct place. It's saying if you get to 315 West Wisconsin and you want the directions to the nearest quick shop, you go up 3 streets and then you go right 12 streets or something like that. The directions to the next point. In this case, the directions for our next point are -3/5. In other words, from the point that we know, we're going to go down 3 because on the rise it's negative. So here it's down 1, 2, 3, right 5. 1, 2, 3, 4, 5. And there's our next point. Another way you could read that is if -3/5 could be the same as positive on the top and negative on the bottom. The answer would still be -3/5. So I could have said, well, my rise would then be up 3, left 5. And there's your next point. So I like to think about those slopes. If I'm reading -3/5 as a slope, I would read negative, that's down, so down 3, and then 5 is positive, so right 5. Down 3, right 5. But once again, if I changed it to positive and negative, the answer would still be -3/5, but this would be up 3, left 5. Either one is the same exact movement if you look at this, because the one that I did as down 3, right 5, I could have done by going up 3, left 5. And the one that I went up 3, left 5, I could have been done the same thing by going down 3, right 5. Those are the movements between the points of the line.